Hi dear students, once again welcome back to our channel. In this video I am giving a quick revision on coordinate geometry, that is lesson 7. Comparatively this lesson is little bit easy lesson, but don't miss mark with overconfidence. Okay, first of all we can revise what all topics we discussed so far. Okay, and in coordinate geometry first we have distance formula. Okay, and the distance of a point from the origin, equidistant idea, section formula. Okay, these are the main topics which we have discussed, and area of the triangle in coordinate geometry, okay, using that formula, that portion is deleted in this year. Okay, so we can revise one by one. Okay, then first of all, what is the distance formula? Okay, that means suppose we in the coordinate geometry we have coordinate axis. Okay, that is x-axis and this is y-axis. Okay, and we know first quadrant, second quadrant, third quadrant, fourth quadrant, positive, positive, the sign is positive, positive. Here is a negative, positive, the first quadrant, both are positive. This is negative and positive. X coordinate is negative because here negative x-axis. Okay, negative x-axis, here comes negative y-axis. And in the third quadrant, both are negative. Okay, negative, negative, and here it is positive, this is positive x-axis and negative y-axis. These are the signs in different quadrants. Okay, if a point lies inside any one of this quadrant, okay, it will carry the sign of this one, positive, positive, negative, positive, negative, negative, and positive, negative. Okay, sometimes the point can lie on the x-axis or on the y-axis. Suppose I am marking a point here on the x-axis. Okay, and we know the general formula. If a point lies on the x-axis, okay, definitely y coordinate is 0. Okay, that means if it is on, if this is origin, the point of intersection of both axes, x-axis and y-axis, we are denoting with the origin and its coordinates are 0, 0. Okay, and I am marking here as this is 0 and this is 1 and this is 2. Okay, suppose this is a required point and we need its coordinates. Okay, that means a point in the Cartesian plane or the coordinate geometry, okay, has both axes, the coordinate, that is x coordinate and y coordinate. Okay, in order to get its value, draw the perpendicular towards x-axis and the y-axis. That is usually we are doing. Okay, since the point lies on the x-axis, okay, how can we draw the perpendicular towards its x? It is already in the on the x-axis. Okay, so it will, x value is the point itself, where it lies on the x-axis, that will give the x coordinate, and y coordinate from this point, draw the perpendicular towards y-axis and it will meet on 0. So that means if a point lies on the x-axis, always is a y coordinate is 0. That means 2, 0, or in general x, 0 is the coordinate of any point on the x-axis. The same way, children, if a point lies on the y-axis, suppose the point lies here. Okay, so from this point we should draw the perpendicular towards x-axis. Okay, this will lie falls on 0. So its x coordinate is always 0, and where it lies on the y-axis, that will be the y coordinate. So any point on the x-axis, its coordinate will be 0, y. Okay, and from this you will get the equation of x-axis. Okay, here equation, this is the general formula of any point on the x-axis. So its equation is here definitely y equal to 0 is the equation of x-axis. Equation of x-axis is y equal to 0 because y is constant. So y equal to 0 is the equation of any point on the x-axis. Okay, equation of x-axis is y equal to 0. The same way, x is equal to 0 is the equation of y-axis. X equal to 0. Idea is clear, children? Okay, and the next point. Okay, this is all about the any point lies on the any quadrant, and if it can also lie on both axes, then what will be the general form, the general coordinate, and what will be their equation of x-axis and equation of y-axis. Okay, see, suppose I am giving a point here. Okay, that means here I am marking 1, here it is 2, okay, one more point I am marking 3. Okay, so I am marking a point here, that is A of, how can we mark its coordinates, children? Okay, wherever it lies, in order to get its coordinates, okay, draw the perpendicular x coordinate. To get the x coordinate from this point, draw the perpendicular towards its x-axis. Okay, and where it falls, it meets the x-axis at 1. Okay, so its x coordinate is 1. Okay, so 1 comma, and in order to get its y coordinate from that point, you draw the perpendicular towards its y-axis. Okay, and it falls or it meets the y-axis on 3 at 3. Okay, so 1 comma 3, see, both are positive values because that point lies in the first quadrant. Okay, see, from this, what is the, this is another way the question can be asked. Okay, from these points you can definitely get one question, children. See, the point is this: what is the distance of this point from the x-axis? Okay, see, x-axis is, this is the x-axis, horizontal axis. From this axis, this is the distance of this point from the x-axis is this one, this marked distance. Okay, that means let it be here A, this is B. AB is the distance, and that will be equal to this distance, children. Okay, perpendicular, right? So that is 3. Okay, this distance will give you 3. From this point, this is 3. That means the distance of that point from the x-axis will give its y coordinate. That point is clear, children? The distance of a point from the x-axis is equal to its y coordinate, that many units. That means here 3 units. It is clear? The same way, distance of this point from the y-axis, this distance is this one, that is from this point, this is 1, that is its x coordinate will give you the distance of that point from the y-axis. Point is clear, children? Okay, that is general form of any point on the x-axis, any point on the y-axis, equation of x-axis, equation of y-axis, and finally the third set is what is the distance of a point from the x-axis. It is none other than its y coordinate, and the distance of a point from the y-axis, that x coordinate will give you the distance of that point from the y-axis. Okay, so you just draw a figure and mark its points, okay, and so that you can easily get its answer. Okay, the next point is distance formula. Okay, for that I am marking 2 points, okay, in the Cartesian plane. Okay, let it be A, and here we have B, that's the second point. Okay, we have to write its coordinates because we have more than one point. We can't represent it by x and y. Okay, so that we have to use suffix x1, y1 and x2, y2 for the point B. Okay, so the coordinates of A is x1, y1. Okay, here B is x2, y2. We should get the distance. Okay, this is the point, suppose. We should get the distance between these 2 points. Okay, so for that distance formula we are applying distance formula. Okay, and let it be AB, distance between 2 points AB, and for that this is the formula square root of x1 minus x2 whole square plus y1 minus y2 whole square. It's a lengthy formula. Okay, the same formula can be expressed in the form, this is also equal to difference of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, but you should remember, children, in order to get the distance between 2 points, okay, take the difference between the two x coordinates of 2 points and take its square. Okay, see children, x1 minus x2, the difference between the x coordinate. B, we are taking the square, that doesn't matter. Okay, here also x2 minus x1 square. Okay, even if we are getting negative sign, when you are squaring, that will change into positive. So the difference between x coordinates, and take it square of the distance between the x coordinates plus, okay, and square of the difference between its y coordinates, and take their sum and its square root. That will give you the distance between 2 points in the Cartesian plane. The point is clear, children? For example, see, suppose we have the points A of 2 comma minus 3, here B of 2 comma 5. See children, the points both having the x coordinate is 2. Okay, that means x1 minus x2 is 0, 0 square. Okay, so we have to consider only y1 minus y2. Okay, y1, see children, 2 minus 0. 2 minus 2 is 0. Okay, so that term get cancelled. Here x1 minus x2 cancelled. Okay, the rest is y1 minus y2 or y2 minus y1. Here y1 is minus 3 minus 5. That is minus 8. Okay, that means you will get here root of minus 8 whole square. Minus 8 is the difference between the y coordinates. Okay, so if you are using this formula y2 minus y1, y2 is 5. 5 minus minus 3, 5 minus minus 3, so minus minus become plus, so 5 plus 3 is 8, so 8 square. Here minus 8, when you take it square will be a positive, children. Okay, so see, you will get here the square and a square root get cancelled, so you will get 8. Understood? That is root of 64. This is equal to root of 64. Here also you will get root of 64, that is 8. So children, this is very important point. To get the distance between 2 points having x coordinate is same. See children, both having same x coordinate 2, 2. So in that case, take the difference between their y coordinates. Understood? Okay, if you are getting negative value, here we have minus 8, take its absolute value, that is positive value. Absolute value means positive value. Okay, so that will give, no need to use this big formula, lengthy formula, so that you can save time. Okay, in the same way, if you have, see A of, instead of this, I am making this 4 comma minus 3, and here 3 comma minus 3. See what happened here? I made this y coordinate the same. See here minus 3 minus minus 3. See, minus 3 minus minus 3, minus minus become plus, so this will be 0. That means the difference between the y coordinate will be 0. Okay, so in such condition, you just take the difference between this 4 and that x coordinate. 4 minus 3, that is 1. So that is 1 is the 1 unit will be the distance. Okay, that means 4 minus 3, that is, and take it square, that is 1, then square root and square get cancelled. So simply take the difference between its x coordinate, that will give you the distance between 2 points, provided if their y coordinates are the same, minus 3 minus 3. If x coordinates are same, you just take the difference between its y coordinate. No need to take it square. That square and this square root in the formula get cancelled. That will give you the distance between the 2 points. It is clear. Otherwise, if both coordinates are different, you have to definitely use this formula. So before you apply the formula, you see that the coordinates. Okay, if that is of this form, okay, you can simply take the difference. Okay, that will give you the distance between 2 points. The point is clear, children? Okay, and the second point is, suppose you are having 2 points. Okay, one point is origin and you can mark any point. Okay, anywhere in the 4 quadrants. Suppose I am marking here, this is the origin and its coordinates are 0, 0, and I am marking a point B here. This is origin. Okay, this is B. Okay, let it be being in the 4th quadrant, positive and negative. Okay, that is 3 comma minus 2. So what is the distance between this point, that is OB? OB is the distance between these 2 points. here one point is origin. Okay, in that case the distance OB is equal to square root of x square plus y square, x square plus y square, that is 3 square plus 2 square. Minus 2 means minus 2 whole square is plus 2 whole square. Okay, that means you will have here 9 plus 4, that is root 13. It is clear that why this comes, because if you draw the perpendicular, okay, and so that you can mark the points. Okay, here you will get this is the distance. Okay, that means this will give you here 3, the distance is 3. Okay, and what is this distance here? We marked as minus 2. Okay, so this will be a right triangle. So Pythagoras theorem OA. So sum of the squares of other two sides, that is 3 square plus 2 square. It is clear? Okay, so this is the way you can easily get, if the one of the point is the origin, you just take the square root of the sum of the squares of x square and x coordinate and y coordinate. That point is clear, children? Okay, that means if the point is on the origin, one of the point is origin, and you can mark any point on the x-axis or first quadrant or second quadrant or third quadrant, the distance between the point and from the origin. Okay, this is the formula, that is root of x square plus y square. Okay, OA. O is the origin. Okay, our next point is equidistant. Okay, see, suppose here we have x-axis. Okay, x-axis, and I am marking 2 points A and B. A and B. So I am marking a point on the x-axis. Okay, see, if suppose we are given that the distance of these 2 points from the x-axis are equal, they are equidistant. Okay, that means you will have of this figure. That means, see, suppose this is the point. Okay, let it be C. Okay, C is the point on the x-axis. Okay, that means you know that these coordinates are x, 0. Okay, see, if you are given the distance between this point from the x-axis is 12 units. Okay, being they are equal, that means you can write here AC equal to BC. AC equal to BC. This distance equal to this, that is the concept. Okay, 2 points are equidistant from the x-axis. Okay, this can be, see, sometimes the point can be, you can mark like this. Okay, equidistant from the x-axis, that doesn't matter. Okay, the concept is this distance is equal to this distance, and you can apply distance formula. Okay, so when you are applying this distance formula, okay, see here you will have your square root, and here also square root. Understood? And see, in order to solve this, you have to eliminate square root. Okay, by squaring on both sides. So we are getting only 2 minutes for one problem. So the first step itself, you can eliminate square root and you can apply the formula x1 minus x2 whole square plus y1 minus y2 whole square. Okay, see, being they are equal to 12, that is equal to 12 square. Okay, the distance between this distance BC is given as 12. Okay, so when you are squaring in LHS, you have to square RHS also. Okay, that means 12 become 12 square. Okay, if it is 10 here, okay, so the distance formula, that is equidistance idea. Okay, so here if it is 10, the distance is equal to, after applying the square root, okay, in the next step you have to square. That means this square root get eliminated. At the same time, this RHS quantity should be squared. Then only it will be equal to x1 minus x2 whole square plus y1 minus y2 whole square. There is no square root, because in order to eliminate the square root, you have to squaring on both sides, means you have to square the quantity in the RHS. Okay, so in the equidistant idea, we are applying the same formula, that is distance formula. That point is clear, children? Okay, and if that point is on the x-axis or on the y-axis, you can write the general formula, that is x, 0 or y, 0 if the point is on the y-axis. That's so from this point also you can expect one question. Okay, and another point is collinear. How can we show that 3 points are collinear? Okay, in that case also we are applying the distance formula. Okay, 3 points are said to be collinear if these 3 points are lying on same straight line. Okay, so in order to prove that, okay, so you will be given 3 points. Let it be A of x1 y1, B of x2 y2, and C of x3 y3. So what you have to do is you get AB using distance formula. Find AB, okay, and BC and AC. Okay, if any one of the side is equal to sum of the other two sides, that means if AB equal to BC plus AC, or if ABC is equal to AB and AC, or AC is equal to AB plus BC, the longest side, okay, is equal to sum of the other two sides, you can say that these 3 points are collinear. Collinear means they will lie on a same straight line. They will not form a polygon, in other words. Okay, so children, these are the different forms of distance formula. Okay, that means we can expect that application of distance formula in such areas. Okay, that is equidistant for idea. Okay, and simply the distance between 2 points, or in order to show that 3 points are collinear. In these 3 cases we are applying the distance formula. So the next topic can be expected from this lesson is how to identify polygon. Okay, here we have only 2 types, that is triangle and quadrilateral. Okay, that means suppose you are getting 3 points. Okay, and how can we show that 3-sided polygon is triangle? Okay, so triangle can be that because of that 3 points that can form either, that is the first type of triangle is equilateral triangle, then isosceles triangle, and third one is scalene triangle. Okay, and when we can show that when that points will form a equilateral, you just form a triangle, okay, and mark the points as the vertices of this triangle if AB equal to, and here also we are applying distance formula, AB, BC and AC, get it? Okay, using distance formula, if all these 3 sides are equal, you can say that the given points will form the sides of an equilateral triangle. Okay, if 2 sides are equal means it will form an isosceles triangle. Okay, here scalene triangle means all the 3 sides are equal. Okay, all the 3 sides are unequal. Okay, if all the 3 sides are unequal, so that points will form a scalene triangle. Square of one side is equal to sum of the squares of other 2 sides. Okay, BC square. In that case, that 3 points will form a right triangle exactly. Okay, so these are the main application of distance formula. Okay, and in the next is the different types of quadrilateral. Okay, in quadrilateral, that means simply quadrilateral or parallelogram, square, rhombus, special type of parallelogram, square, rhombus and rectangle. Okay, see, so in that case you will be getting 4 points. Okay, when you can say that those 4 points will form the sides of a parallelogram. Okay, parallelogram means that the opposite sides are equal and parallel. Okay, so here if the point is if both the sides are, that is opposite sides are equal, that is if it is A, B, C, D, AB equal to CD, AD equal to BC, in that case it will form a parallelogram. But in this rectangle also, okay, opposite sides are equal. Okay, that means, so when we can say that 4 points will form a rectangle, or when we can form that points, we can say that will form a parallelogram. Okay, so in rectangle, okay, how can we say that, what is the difference between a parallelogram and rectangle? Has additional property, and for that you have to find its diagonal. The diagonals are equal, opposite sides are equal, and diagonals also equal. You find AC and BD using distance formula. Okay, and if both are equal, you can say that it will form a rectangle. Okay, if diagonals are unequal, it will form a parallelogram. Okay, in the same way, rhombus and square. Okay, if you, after using the distance formula, if you see that all the four sides are equal, that is AB equal to BC equal to CD equal to AD, that means it will form two chances. Either it may be a rhombus, okay, rhombus. It can be a rhombus A, B, C, D, that is all the four sides are equal. And the second choice is it may form square. Okay, in order to say that it will form exactly square, you have to find its diagonals. Okay, all sides are equal and diagonals also equal. AC equal to BD. In that case, that 4 points will be the sides of a square. If all sides are equal and diagonals are unequal, it will form a rhombus. Okay, so a distance formula has so many applications, so many areas we can expect questions. So thoroughly understand which area we can apply the distance formula. Definitely we can expect 1 or 2 questions from this topic. So the last topic of this lesson is midpoint formula and section formula. Okay, see, for that we have 2 points, so A and B, and its coordinates are x1, y1, and B, its coordinates are x2, y2. Okay, x2, y2. Okay, see, I am going to divide this AB, the line segment AB, exactly in the midpoint. Okay, so let the point P divides this AB in the ratio 1:1. Midpoint means 2 equal parts, AP equal to PB. If P is the midpoint, okay, how to get the coordinates of P? And we represented the coordinates of P as x comma y. So that means we should get the x value of P using the formula x1 plus x2 by 2. x1 is the x coordinate of this A and x2 is x coordinate of B. Take their sum and take its half. Okay, and in order to get the y coordinate of this point P is y1 plus y2 by 2. Okay, so provided the point P definitely will be the midpoint. Okay, in some cases point P will not be the midpoint. That means the ratio will be different. The first value and second value, antecedent and consequent will be different. Okay, that means what I meant is 2:3 or 1:3. Okay, 3:4, 2:5. That means if we are giving a ratio, means that point P will not be the midpoint. In that case, we cannot use this formula, that is x1 plus x2 by 2 and y1 plus y2 by 2 in order to get the coordinates of P. And for that we have section formula. Okay, that means here if the point P is not the midpoint, sometimes it can be here, okay, P of x comma y. In that case, the coordinates of x, that point P, that is x value, is mx2 plus nx1 divided by m plus n. And in order to get the coordinates of y, we have my2 plus ny1 divided by m plus n. In both cases, the denominator is the sum of the ratio, and here if we need x, there is no y value. Okay, mx2, m into x2 plus n into x1 divided by sum of the ratio. Here also m into y2, we need y, and the denominator is in terms of y only. Okay, so these are the way you should get, we can easily get its x value and a y value. Okay, that means if provided the point P is not the midpoint, you have to use section formula to get that required points. Now the next point is how to get the coordinates of the centroid of a triangle. Centroid means it is the meeting point of all the three medians of a triangle. So suppose children, we have a triangle. Okay, so the medians A, B, C are the vertices. Okay, from the midpoint. So here comes the centroid. So let it be P, this point representing P of x comma y. So we need the x coordinate of this point. That means here the point denotes the centroid of this triangle, and in order to get its coordinates, x is equal to x1 plus x2 plus x3. We have three vertices for a triangle divided by 3. Okay, and y is equal to y1 plus y2 plus y3 by 3. Okay, this is the another point can be expected from this lesson. Okay, another types of question. Okay, one more type children regarding the direction. Okay, see, direction means we need a direction that is north. Here this is south, this is west, and this is east. Sometimes a flight is starting from a point, let it be 0, 0 origin, starting from the origin, and it flies towards north, that means upward direction. Okay, from this it and after covering 1500 kilometers, it changes direction and it flies towards east. Okay, that means from this point it flies towards east after flying 1000 kilometers. And what is the distance between this airport and the after covering 1000 kilometers towards east? Okay, so this is the distance. Okay, so after towards east covering this 1000 kilometers, let it be B, this is A, this is a starting point origin, so OB. Here also you can apply that formula, that is a distance between a point from the origin to this point. Okay, so these are the main topics, that is areas that coordinate geometry can be expected. Okay, that means based on this you can expect a case study also from this lesson. So this is all about the coordinate geometry. Okay, so thank you children, thank you for watching and supporting my channel, and may God bless you all and all the very best for the examination.